Basic Chemistry, Lecture 2. So our last lecture, we got to understand a little bit what matter was, elements and their atoms. We got to examine atomic structure and get into types of models such as the electron cloud model and the Bohr model. And we also were able to determine the types of subatomic particles and how many of them would be found by looking at the periodic table, how many would be found in each atom. And then we concluded our discussion last week with isotopes. So all that information is important for this next step when we talk about atomic structure and elements and atoms, because what we are going to see now is how atoms are going to react with one another to form molecules or compounds. So in our first discussion, we were talking about matter, and we looked at what matter as far as pure substances being, and we said that that would be elements, and now we're going to be introduced to compounds. These are both pure substances, which are different from mixtures, which are not pure substances because they do not have fixed proportions like we see in compounds. So ultimately what atoms are trying to do is to become stable, and they become stable when they have a full outer shell of electrons. That means they have a full outer shell of 8 electrons, as seen in the group 8 elements, the noble gases, or what we refer to as the inert, non-reactive gases. Atoms exchange electrons in order to have a complete outer shell or valence shell. So that outermost shell is called the valence shell, and those outermost electrons are going to be the valence electrons. The group number for the element, so we have groups 1, 2, 3, 4, 5, 6, 7, and 8. The group number that element is found represents the number of valence electrons found in the outermost shell. So here you could see group 1, all of them have 1 valence electron. Group 2, they all have 2. Group 3 has all 3 valence electrons, all the way down till you get to group 8, where you have the noble gases. Now I told you the exception in group 8 was helium because it only has 2 electrons. However, it is an inert gas because helium fulfills its first energy level, which could hold 2 electrons maximum. So by having 2 electrons, it meets the requirements of being an inert gas. So here are the models of the 6 elements that are predominant in living things: hydrogen, carbon, nitrogen, oxygen, phosphorus, and sulfur. And here you can see a somewhat of a Bohr representation. Remember, Niels Bohr said that electrons are found in fixed distances from the nucleus in the region that we call orbitals or shells. So what are compounds and molecules? A compound is 2 or more different elements that are bonded together. Molecules are the smallest part of a compound that still maintains the properties of that compound. So what creates compounds and molecules are these things called chemical bonds. And a chemical bond is basically the force of attraction between 2 or more elements. That force of attraction could be differences in charge, or it could require the atoms to be sharing electrons. So our first type of bond type is called an ionic bond. An ionic bond occurs when electrons are transferred. An ion is an atom or molecule that has either lost or gained an electron. When you lose or gain an electron, these atoms are going to form charges. An atom that would lose an electron gets a positive net charge, and that would be called the cation. An atom that is going to gain the electron gets a negative net charge, and that will become the anion. So atoms that lose or gain electrons get a net electrical charge. That is an ion, and there are 2 types of ions. You have the anion, which is an atom with a net negative charge, and you have a cation, which is an atom with a net positive charge. Now, ionic bonds occur between atoms that are metals and nonmetals. And when we did our periodic table together, we said that ionization energy increases as you come up in a group and go over from hydrogen toward helium. The ionization energy increases. Therefore, as you come over towards the halogens, the ionization energy increases, that means it takes a lot more energy to remove electrons from those atoms on the non-metal side of the periodic table than it does from the metal side of the periodic table. So what's easier for atoms to do in ionic bonds is for the metals to give up their electrons to the nonmetals. In doing so, the metal element will become the cation and the nonmetal element will become the anion. When you start to get those charges, ions with opposite charges attract and form bonds called ionic bonds. So here we have charge differences. An atom with a positive charge will become electrically attracted to the atom with a negative charge. We also call this oxidation reduction. So when an atom loses an electron, it's oxidized. When it gains an electron, it's reduced. So that is an oxidation reduction reaction. And here we could see an example of an oxidation reduction reaction or ionic bond between the sodium atom, Na, and chlorine atom. So you can see sodium being a group 1 element has 1 valence electron. It's going to give up that 1 valence electron to chlorine, which has 7 valence electrons in the halogen family, group 7. So it is much easier for sodium to give up that 1 valence electron than for chlorine to give up its 7 to sodium. And when sodium does give up that 1 valence electron, it gets a charge of 1 plus, and chlorine receiving that electron, which is being reduced, it gains a charge of 1 minus. A charge of 1 plus is attracted to a charge of 1 minus, so that force of attraction there becomes the ionic bond, and the compound that you form is sodium chloride. And if you look here in the diagram, you could see that ionic solids are called crystal lattices. So here you could see the smaller orange sphere represents the sodium ion, and the larger green ones represent the chlorine anion. And they orient themselves so that you have the positive being attracted to the negative charges. And here you can see salt crystal. Sodium chloride is common table salt. One note to look at, the non-metal here would be chlorine, the metal here would be sodium. When you're naming ionic compounds, you keep the full name of the metal and you drop the ending to the non-metal and add IDE. So the name of the ionic compound here would be sodium chloride, or you could use calcium bromide, for example. That would be a salt formed between calcium bonding with bromine. We'll do some practice of ionic bond formation in class. The other type of bond formation is covalent bond formation, and it occurs when electrons are shared. When two atoms do not have a completely full outer shell, they must share electrons so that each has a full outer shell of electrons. Covalent bonds are formed when a nonmetal is combining with another nonmetal. And we have an example, hydrogen gas, that we'll look at. The bond notation, there are types of bond notations. Here we see a single covalent bond between hydrogen gas, which is represented by one line, so that means 2 electrons are being shared there. You have a double covalent bond with oxygen gas, O2, and here we see 2 pairs of electrons being shared between atoms. And then nitrogen gas would represent triple covalent bonds, and they are written as N with 3 dashes in between the 2 ends, and that would be 3 pairs of electrons being shared between those atoms. So here we have a nonmetal bonding with a nonmetal, and it will fulfill the outer shell requirement by sharing electrons. Electrons are not going to be exchanged here. So if you look, here you can see that hydrogen gas is here. Here is its structural formula. Here is the molecular formula. Down here we see oxygen gas. There we see the 4 electrons being shared, or what we would say as 2 pairs, indicated here in the structural formula. And then here is its molecular formula, O2. Remember that the number is written as a subscript, tells you the number of atoms for that particular compound. Here's another one. This would be methane, CH4. Here's its structural formula. Here's its molecular formula. So CH4, that 4 written as a subscript after the hydrogen, means that it has 1 carbon atom and 4 hydrogen atoms. Other types of molecular molecules, in this case, for methane, here you can see the ball and stick model for methane, and here you can see a space filling model for the methane molecule. So we will go over covalent bonding as well in class and reinforce some of these basic chemistry concepts. So when we talk about chemical reactions, we see that the exchange of electrons between atoms or the sharing of electrons create chemical reactions. And if you look, here is the chemical equation where you have 6CO2, which is carbon dioxide, plus 6H2O, which is water, yielding C6H12O6, glucose, plus 6O2, oxygen. This is our molecular formula or chemical formula for photosynthesis, where we have carbon dioxide bonding with water to form glucose and oxygen. So this is the equation for photosynthesis. Now, on this side, which would be the left side of the chemical equation, we have what we refer to as the reactants. On the right side of the chemical equation, we have what is commonly referred to as the products. So the reactants would be like the ingredients to make a cake: the milk, the flour, the sugar, the eggs. The product would be the cake itself. So the reactants are carbon dioxide and water. The product will be glucose and oxygen. And if you count the number of carbon atoms and oxygen atoms and hydrogen atoms on the reactant side, it should be equal to the carbon, hydrogen, and oxygen atoms on the product side. That would be a balanced equation. The last type of covalent bond is that between a nonpolar covalent bond. A nonpolar covalent bond is when the sharing of the electrons between two nonmetals is fairly equal. And that is because the electronegativity difference, or the attraction of an atom for electrons in a covalent bond, is very equal or the same. In polar covalent bonds, you have unequal sharing of electrons between atoms, and that is due to differences in electronegativity. So a nonpolar covalent bond is when the electrons are being shared equally. A polar covalent bond is when you have unequal sharing of electrons. And that will take us into our next topic, which will be the properties of water. That's all for bonding.